right, so when I was first introduced to the QualiTru system a number of years ago, I saw this idea of using a pump in a bag to develop a sample of what's in your process line is pretty unique, and I kind of liked it. And but really, there's a math reason behind this. And so what I'll do is I like using whiteboards. I like graphing stuff because I'm an engineer, and pictures do well with us. So let's say I have a curve of some sort or another like that. And this might be representative of the milk flow through the line or something within our process. So if I come in here with a syringe, a 2-inch syringe, and I've got milk flowing through my line, and I take a sample with the syringe, I get this. That's what I get from my sample. It tells me a lot about what was in the line at that particular point in time, but it doesn't tell me anything about what's happening out here. Right? So not a bad deal, it's not ideal, and it doesn't give me all the information that I need. So what if there's some other sample mechanisms out there on the market that kind of work like this. So they'll take a sample here, and then sometime later they take a sample here, and sometime later they take a sample here. And while I'm getting a lot of samples, and when I aggregate these samples together, I get a fairly representative idea of what was in the line. But what if I took a sample like this, that I kept taking these small samples, right? So what happens is in math, it's called an integral. So one of the things you learn in calculus and as engineers is that sometimes I want to find how much area is under this curve. And there's a technique that's been devised in the mathematical community called an integral. And if I know the equation of this line, I run the integral, and I can literally calculate how much area is under the curve by essentially breaking the curve up into very, very, very small rectangles, and then adding all those rectangles up, and then I find out the area under the curve. Or our peristaltic pump and our sampling bag work very much the same. The pump runs continuously and takes a very small microsample all the way along this process, the whole time this process is running, until you get to the end. And now I have a 2-liter bag down here full of milk or liquid egg or juice or whatever it is I'm trying to sample in my line, and this 2-liter bag looks almost exactly like what was in this line. It's extremely representative, and it's much more representative than if I just come in here and take a snap sample at some point in time along my process. And so that's why this 2-liter bag full of fluid, milk, liquid egg, juice, whatever it happens to be, that's why this bag looks much more representative of what's happening in your process. And it could be, this could be a sample that you're taking off from a process line in a plant. It could be you're unloading a silo into a tanker truck. It could be that you're milking a pen of cows, maybe 60 to 100 cows in a pen, and milking those pen of cows into a large bulk tank or a large silo, and you want to understand what's going on with each pen of cows. Now I can run the same process and get a 2-liter bag of sample that's very representative of the original product, the 60 cows, the process line. So let's say this milk was going onto a large truck, and I milked multiple pens throughout this 12-hour period in between my clean in place cycles, in between CIP, and I milked, and I was taking a sample of all that milk that was going on the truck. So now I've got a truck out here with what, 60 to 70,000 pounds of milk on it. This 2-liter bag looks exactly like that 70,000 pounds of milk on a truck.